Graphing radical functions, part 2. We're on example 3, modeling real life. The function ed equals 0.25 times the square root of d approximates the number of seconds it takes a dropped object to fall d feet on Earth. The function md equals 1.6 times ed approximates the number of seconds it takes a dropped object to fall d feet on Mars. How long does it take a dropped object to fall 64 feet on Mars? All right, so the first thing we know is that we're given two different functions, and they represent the number of seconds it takes. The first one, ed, for an object to fall d feet on Earth. And the second function approximates the number of seconds it takes for an object to fall d feet on Mars. So we're asked how long it takes to drop an object to fall a given distance on Mars. So that's what we're looking for. So first thing we need to do is multiply ed by the 1.6 and write a rule for m, because you can see that this says 1.6 times ed. So let's go ahead and write a rule. So md equals 1.6 times 0.25 times the square root of d. All right, and then we can multiply the 1.6 times 0.25. Since we have two numbers in front of the radical, we can combine those numbers. So let's see, we've got 1.6 times 0.25, and that's going to equal 0.4. So we can just clean this up a little bit and put 0.4 times the square root of d, and that's going to be m of d. Then we need to know, how long does it take a dropped object to fall 64 feet on Mars? All right, since d is in feet in both of these equations, all we have to do is substitute the 64 in our equation. So we're going to have md equals 0.4 times the square root of 64. The square root of 64 is a perfect square. So the square root of 64 is 8. And then we just have to multiply 0.4 times 8, which is probably 3.2, since there is a decimal place here, and 4 times 8 is 32. Going to check just to make sure. So 0.4 times 8. And that gives you your 3.2. All right, so that tells us it takes 3.2 seconds for a dropped object to fall 64 feet on Mars. Example 4, writing a transformed radical function. Let the graph of g be a horizontal shrink by a factor of 1/6, followed by a translation 3 units left of the graph of f of x equals the cube root of x. Write a rule. All right, so I've attached these key ideas. Hopefully you have your notes handy, and these are in your notes, and it will make it easier to write a rule. So the first thing we need to see is that we have a horizontal shrink by a factor of 1/6. If you have a horizontal shrink by a factor of whatever, you have to make sure that you do that by 1 over a. So 1 divided by a in this case is 1/6. Okay, so we're going to do 1 divided by 1/6 first. And remember, dividing a fraction by a fraction, and you can write 1 as 1 over 1. Then you multiply by the reciprocal of that. So that's going to be 1 times 6, which is just 6. So that's going to be the number we need coming from this horizontal shrink here. And then we have followed by a translation 3 units left. And remember your horizontal translations, if it's left or right, it's going to be underneath the radical sign, and it's opposite the sign you expect. So to go 3 units left, you're moving in the negative direction, but it's actually a positive number under here because it's always x minus h. And x minus -3 makes that a +3. So what we need to do is take that information and write a rule. So we're already given f of x equals the cube root of x. That's our parent function. And g of x is going to be, first we can plug in the 6. So we're going to have f times the 6. So we're going to have f of x times 6x. So what that's going to do is plug that into our function. So we're going to have cube root of 6x. So that takes care of this part here. And then, and sometimes people use a different, since we're going to have 2 different functions here, sometimes people use h of x or something different here. So we can do that if it helps. I don't want to confuse you that we're going to have 2 different functions with the same name. So h of x just applies the horizontal shrink, okay? And then we're going to take this new function, the cube root of x with the horizontal shrink, and now we're going to apply the translation 3 units left to that. So we're going to have cube root, and we've got 6, but we're going to have x, and 3 units left again is +3. So what's going to happen is you really have to distribute if you want to simplify that. We're going to have g of x equals cube root, and you can see that 6 times x is 6x, and 6 times 3 is 18. So if you want to clean this up a little, 6x plus 18 is the best function, or the simplified function. This is equivalent to that, but if you don't remember these parentheses here, you might get lost. You know, 6x plus 3 is not the same thing as 6x plus 18. So make sure you remember this x minus h is going to be in parentheses there. All right, that is all for lesson 4.3. If you have any questions, please let me know.